Hello, Class 8. I'm going to answer your questions today. People sent in a lot of interesting questions from your class. I'm going to start with one student asked, can you show how to get electricity from a lemon or a potato? That's a great question. So I just want to talk a little bit about what that's all about. Turns out that you can use lemons or potatoes to make a type of battery. So you're going to need a piece of zinc and you're going to need a piece of copper. The piece of copper, you could use penny, which is coated with copper. And for zinc, you could use some nails are coated with a layer of zinc on top of the steel, which they're usually made of. Now, you may not know this, but everything that is made of matter, that's anything that takes up space, you, the air, your furniture, really anything you could think of, are made of tiny little particles called atoms. And these atoms contain even tinier particles called electrons. So for most materials, the electrons stay close to the atom, but for other materials like metals, which zinc and copper are metals, the electrons tend to flow from one atom to another. And for copper and zinc, the interesting property that's important in being able to make this battery is that zinc atoms tend to dump electrons to copper. So when they come in contact, they'll quickly dump electrons. And it usually happens really quickly, but if they're placed in certain liquids, such as an acid, so think of lemon juice, or a base, think of potato juice, we can actually force the zinc to keep giving up electrons to the copper. And when we connect it in something called a circuit, where the electricity can go around and around, or the electrons can go around and around, kind of in a circle, we can make the electrons flow. And the name for that, when we have flowing electrons, is simply called electricity. Now, let me show you a little bit in a diagram of what that would look like. So here is a diagram. You would need these supplies. This thing right here is called a voltmeter. It's used to measure electricity. It's just going to show that there is some electricity. You're going to roll the lemon to loosen up the liquids so that the electrons have something to flow through. You place a penny and zinc into the lemon, and when you connect it in a circuit, that's these wires, you see this number 50, it's over 50, that means you're generating electricity. And if you connect enough of them together, you could actually make a battery that produces enough energy to at least make a small LED light go on. We're not talking about a very strong battery here. All right, let's go on to our next question. Next question, a student asked how hot the sun is. So I'm actually going to go to a diagram of the sun right now. And if you were to cut open the sun, which obviously you can't do, it might look something like this. These are the different layers of the sun. Inside the core is the hottest part of the sun, and that's about 27 million degrees Fahrenheit. As you travel away from the center of the sun, it starts to cool to a much cooler but still very hot 7,800 degrees in the chromosphere. That's that outside layer of the sun. Now, the sun is surrounded by something called the corona. That's just particles of gas being shot out of the sun. And that word probably everybody's a little sick of hearing. It just means crown in Spanish and Latin in ancient language. Um, for reasons that aren't really understood, it gets even hotter, even though it's cooler on the outside. It gets much hotter on the outside, up to over 1,000,000 degrees Fahrenheit. And scientists actually don't know exactly why. They're still trying to figure that out. All right. And that actually leads me to a follow-up question asked by another student in your class. How fast does light travel? The answer is right here. It's 186,000 miles per second. Now, just to give you an idea of how fast that is, that's really, really fast. That's over 670 million miles per hour. Now, a jet, by comparison, travels at about 500 miles per hour. That's over a million times slower than the speed of light. Uh, and it would take, so speaking of the sun, it takes the light from the sun about 8 minutes to get to the earth. That's how far away the sun is. The sun's very far away from us, but it still takes, the light travels very fast, so it gets to us in about 8 minutes. It doesn't happen actually instantly like some people think. All right, next question. Student asked, how do you program technology? So that's actually a very complicated question. So I'll try to give you as simple an explanation as I can. Basically, all the applications on your computer, your phone, game systems are controlled by computer programs. Video games, word processors, websites, web browsers, you name it, and instructions that are basically a recipe for making a program do what it's supposed to do. All right, so to give one example in a video game, uh, one part of the program might control how the character responds to a key press. So if you press the space bar, maybe the character jumps or something like that. Now, as I said, it's a lot more complicated than that. Um, just to show you an example of an actual computer program, it looks something like this. All kinds of gobbledygook, which doesn't necessarily mean anything to me or you, but it means something to a programmer and helps the computer do what it's supposed to do. It's basically a series of commands that are directions telling the computer what to do. Um, More interesting for you guys, if you're interested in programming, you can go to this site called Scratch, and it's located at scratch.mit.edu. MIT is a university, and this is the homepage, and I'm going to click on Create. You could also join, but you don't have to. That just allows you to save work. And when you go to Create, you'll go to a page that looks like this. You could do some tutorials if you want, but I'm just going to click out of that. And I'm going to slide this piece into the middle. And watch the cat while I click it. It's going to move 10 spaces to the right. If I change that number to 20, it's going to move a little faster. Now, if I want to move it in the other direction, I turn it into a negative number, like negative 20, and you'll see the cat's moving backwards now, right? And I could stack those. So it's a series of commands. And when I go to this control button, no, not control, events, and I put that there, that's the green flag is going to start my program, and you'll see it's going to move forward and then backwards. You weren't able to see that too well, so I'm going to do a little pause. Let's move 100. Okay, so it's actually, it's hard to see, but it's doing both of those. And you could really play around with this. It's a really cool platform that it's just open to experimenting, and you could do all sorts of things and design backgrounds and stuff. And like I said, there's this tutorial button you could press, which is going to open up all sorts of tutorials for you to follow along with. I might make a follow-up video about how to do that. So let's go back to our last question. A student asked, how do you get a paperclip to stick to a magnet and float? So you might remember we actually did this in class. The first part of the question, how do you get the paperclip to stick to a magnet, is easy because a paperclip is usually made of steel. And remember, a magnet will attract anything made of iron or steel, which is a type of metal that contains iron. So I'm going to click on this diagram just to remind everybody about how we made the paperclip float. And there you have it. We had the non-touching force of the magnet pulling up the paperclip while gravity was pulling down the same amount of force, and it was balanced, so it seems to be floating at the end of a string. Now, if we change anything, like we blow it over, the force will between the magnet and the paperclip will become less, and it will fall out of balance until it hits the ground. And there you have it. Thanks for all your questions, Class 8. Maybe we'll try this again.